Welcome, software engineers, to day 10 of CSC 222. Thank you for being here today. Yes, today is the day of our first exam, but as I advertised before, I just want to chat with you for a couple minutes, and then I'll turn you loose on the exam. The exam, as I mentioned before, is you'll take it on the honor system. Don't discuss it with anybody else, and don't use any online resources. It is okay to use the text and the book and any of the notes that you find at Blackboard. That's all okay. But of course, recognize that the exam is timed. You'll have 45 minutes to complete the exam, so you won't be able to look up everything. But that is there to allow you to double check some things, or if something just you have no idea, you have an opportunity to take a look at it. So we're on the honor system, open book and notes, closed online resources, and closed neighbor. Thank you. Try to remember to, because I'm not always convinced Blackboard does a good job at this, and I know it's just my own failing with Blackboard too. But today, homework assignment 11 is due. That's sprint 3 of our Add Nums program. And Wednesday, then, CNCS 4 is due. We've kind of moved from a Monday to a Wednesday discuss and do thing with the CNCS assignments there. Let me just mention that if for some strange reason you've gotten a little bit behind in this class, ordinarily, I do not allow late assignments. It's just so much additional work to try to get back into it. And then oftentimes it doesn't really seem to help. But if you are missing an assignment here in Unit 1, send me a mail message, explain why you're missing that assignment, and I'll very likely give you the opportunity to submit it. It will not be worth full credit in deference to those who did it on time, but it's much better to get some partial credit rather than having a 0 hang out there. So take a look. Be sure you look online at Blackboard. It should show you everything that has been due and graded. Check to see if you have anything missing there. Also, it's a good time just to double check what your current standing in the class is. What's the grade that you have right now? We completed week 5, moving into week 6. And at Irvine, at the end of week 5, I and all your instructors are supposed to, anybody who's performing below a C level, you're supposed to be alerted to that fact. So I went through that system. Hopefully it sends you a note. Your advisor gets a note too. I think for the vast majority of folks, you could do it. You just got to do the work. So here's the opportunity. Get this done. Let's move on from here. Questions, concerns, please contact me. And yeah, some of you noted, you can send it to my CUW email address. I see that a little more often than the Irvine email. I'll respond to both of them ultimately. Some of the things we're going to sort of review today might find their way on the exam. So we've described software engineering as professional problem solving. And I want to talk again a little bit about this one that we introduced last time, being a team player as an aspect of professionalism. Sorry, I couldn't show you the very funny Chuck Norris clip. Not going to spend the time doing that today, but you all recognize that being a team player is a characteristic, a hallmark of being a professional. I've related each of these aspects of professionalism to one of the commandments. We've worked our way up to commandment 4, honor your father and mother. And you might wonder, wait, what's that have to do with being a team player and other kinds of things? Well, to help us with that, let's take a look at Luther's explanation to the 4th commandment. Because although this may seem very specific and limited, it wasn't that way to the people God talked to, the Hebrews of the day, and it shouldn't be limiting and specific to us either. Notice Luther says, fear and love God so we do not despise or anger our parents and other authorities. So in context, father and mother, absolutely. But that also includes other masters, other figures of authority. But instead, honor, sorry, I got something popping up here. Honor them, serve and obey them, love and cherish them. Good. So realize the fourth commandment also relates to bosses. This is the CEO of Dilbert's company. Government regulations prevent us from marketing our products the way we want. What should we do? Dilbert, I'll consult my bundle of bumper stickers for some guidance. Question authority. How did you get so smart? We've talked about Jesus' disciples. Did you notice this? Jesus went around teaching from village to village, calling the 12 to him. He sent them out 2 by 2 and gave them authority over evil spirits. Good. Is everyone ready to go to lunch yet? I've been waiting for 90 minutes. We just got back. No one noticed you weren't with us. How was your team building lunch? Suboptimal. I won't ask you anything about this on the exam, but it's just something that software engineers need to have heard of. It's one of those things in the annals of computers, sort of like that Gary Kildall story, the man who could have been Bill Gates. This is a story, the development of the IBM PC. You know what any of those letters stand for. IBM is a company. At one time, they were the largest computer company in the world. They were the largest manufacturer of personal computers, PCs. Yes. The IBM PC was developed over the course of 1 year, which is a pretty aggressive timeline for a huge company like IBM. So the project manager, Lowe, picked a group of 12 strategists who worked around the clock to hammer out a plan for hardware, software, manufacturing setup, and sales strategy. It was so well conceived that the basic strategy remained unaltered throughout the product cycle. What's notable about that is today, this basic strategy, we would call requirements and specifications. It is so unusual for folks to either spend time thinking about that or to actually do it so well that it remains very much unchanged throughout the product life cycle. Eastridge, who is the president of IBM, decided early that to be successful and to meet deadlines, the group had to stick to the plan. So, something else comes up? Nope, not doing that. Stick to the plan. Using tested vendor technology. IBM didn't create too many pieces of their own PC. This is the start of OEMing, grabbing a part from here, there, and everywhere and putting it together. A standardized one model product, open architecture. Yep, anybody could design for either the hardware or the software. This is a radical departure from what Apple was doing and continues to do today. Open architecture, anybody could see the specs for the hardware, make their own piece of hardware to plug in. And you remember the story of the software. IBM didn't create the operating system. IBM asked this other company, Microsoft, to do it, and they didn't do it either. They just bought it from somebody else. This is an amazing story of a team with a great strategy, an opening good requirements and specification, or a wonderful idea actually solving a problem. Okay, let's review a couple things because they will be on the exam. And no doubt you want to know how they fit into the rest of the world. Software engineering is a creative activity. We are creators. Unlike coders programming in the small, just hacking out some little thing here, software engineering programming in the large, right, This is an entire development process. What are the three aspects of creation? Number one is idea. Idea is the mental model. For us in software engineering, that means requirements. During the requirements phase, the problem is identified and specifications. So requirements and specifications, that's the idea of software engineering. Once the idea is developed, then comes implementation. This will be the focus of our unit 2, where we'll really talk about design and instantiation, the coding. You've done both of those activities, but we really need to see how to do them well, and especially how to do them as part of a team. The third aspect of creation is interaction. Oops, I'm sorry. I didn't tell you what implementation is. You got this great idea in your mind? Wonderful. You got to get it out of your mind in a very concrete form. Using hardware, develop the software, and we've got a system that solves a problem. So you're thinking we're done. No, we're only done once the user interacts with our system. Interaction is the third aspect of creation. Late, we're going to see, oh, that includes ideas like deployment and maintenance to allow the user to interact and interact well. But no creation is worthwhile until someone interacts with it. Speaking of creation, when you create an algorithm, that's what we do in software engineering, there's an order, there's a way to approach this. First of all, it's OIP, OIP, output, input, process. That's the order you think of when you're creating something like a software system. Well, you'll note this is exactly what we have done. Let's delve in a little deeper. So I mentioned during the requirements phase, the problem is identified. Okay. What are we really focusing on in the requirements phase? The output. The output information determines how the user is going to solve the problem. Yeah. What information do I need in order to solve this problem at hand here? So one purpose of the requirements phase is to determine user needs. Determine user needs. What's the user need? The information, the output that our system is going to generate. Cool. All right. After we do requirements, then we talked about milestones and what requirements is all about. And you're going to tell me about that today, right? Explain the requirements phase. Good. Then comes specifications. Notice that I have both outputs and inputs under specifications. And you say, wait a minute, go back. We do output in requirements. True. But sometimes after we go through the requirements and begin the specifications, we might need to tweak those outputs a little bit. If not, that's fine. But part of specifications is to specify fully all the outputs and all the inputs. And by inputs, I mean not only data, but also any commands. Okay? So we determine both the inputs and the outputs of the proposed system during specifications. The purpose of specifications is to explicitly describe the functionality of the product. What's it do? What's it look like? What are its features and functions? Now, you've done design, but we haven't discussed it. We'll do that in depth beginning in the next unit. Now in design, yeah, we're still going to consider outputs and inputs and also the processing. It's at this phase that we consider how. We consider algorithms. We consider data structures. Before this stage, that's not really on our mind. Other things are. One thing that we can't really do, our specifications document includes lots of things, and it also includes project planning, estimation of time, resources, cost. You mentioned a couple of ways of doing that. The heuristic way, the rule of thumb. I've done it before, so maybe this is what will happen. Or an algorithmic way, using a formula to do those estimations. Specifications includes project planning. Zip. I recently took a poll. What was the response? 100% were angry when their tent collapsed. Doesn't work really well when I have to put it on the slide. See, I want to just say the word poll, which could be a homonym, right? I mean, P-O-L-E, P-O-L-L. Nobody's in the mood because a horrible thing happens in just a minute. Now, you will find the exam online at Blackboard. A couple things to say. Once you begin the exam, there is no pause. Don't pause and don't back out. Stay in the exam on Blackboard. If you back out, it will automatically submit. If you pause, the timer doesn't pause, and you have 45 minutes to complete the exam. So feel free to take a couple of deep breaths, and when you're ready, go do it. You do not have to stay connected here on Blackboard. I'm going to stay here because if you have a question or something goes wrong, feel free to either chat, or if I don't notice, because I have to look at this screen over here to begin grading assignment 11. Just unmute and say question, and I will hear you, okay? So thanks so much for your hard work so far. We're a third of the way through the class. Don't panic, do your best, and good luck. If you want to stop, you may. I'm going to stop the video, and I'm going to pause. I'm going to stop the recording now, but I'll still be able to hear you, so either chat or say something if you have a question.